going to make Wi-Fi LED control on and off using this WEMOS D1 Mini clone. This is a Wi-Fi module and also a microcontroller. We're going to we're going to blink this LED on and off to be connected to the module. So to do that, we need to download the code. We're going to use the Arduino code for this module. So this is Wi-Fi ESP8266 MOD. But the model, this is WEMOS D1 Mini clone type. The reset button and the USB driver we're going to use is CH340G or 340. What is the use of this IC? The use of that IC, this IC is so that we can connect it to the computer. This module, we need a USB driver, and this one is the IC so that we can upload the code to blink on and off this LED with the use of Wi-Fi, this Wi-Fi module. So let us see if we have the USB driver already installed into the computer. So let us connect it to the computer via micro USB, and the other end is connected to the computer. Connect it to check if there is a driver. So this is a previous program, blink LED. Now we're going to check the computer if there is a USB driver. So here we are using Windows 10, the operating system, and then go to the device manager to check the driver of the port or the USB. Here at the device manager, click port COM and LPT. So clicking that, so you can see here USB serial CH340 COM7. So it means we have a USB driver. If there is no USB driver, you need to install this USB driver so that we can connect it to our computer. If you don't have the driver, we can look that in the Google. You can download it from the Google. USB serial to CH340 driver USB. So we have the driver and it is successfully installed. We already have the installation already installed. So it is now ready to upload the code. So from this module, this is the antenna, some pins, AO, DO, D5, D6, D7, D8, 3, B3. Reset, RST. 3B3, 3.3 volts. 5 volts, G ground, D4, D3, D2, D1, RX, TX. So these are the digital pins or the pin outs. 5 volts and 3 volts. These are supplies. This is not a voltage in. So when we measure the 5 volts to the ground using a tester, we can measure it 5 volts. And here 3.3 is also present here. 3.3 volts. When you measure 3 volts to the ground, G, and then 3 volts, this is 3.3 volts. So the blinking is because I tried it already. That is the blinking LED. And then to the other side, the same. And then this is the USB driver with some components. Reset switch to reset the program. So the same. So we need to, there is here is included when you buy the item. This is what is included in the package. Included is a pin header to be connected here. Where? Here. This one. And then the other one. So we're going to solder this module. Others, or you can connect it the other way around, or this is a female header like this one, or you can connect with this long-legged pin header. So these are all from the package, inclusive. And then let us now see the Wi-Fi program from our computer. Let us check that. Using Arduino IDE, the code, or we are going to see the code. So this is now our code. From here, we have the ESP8266 Wi-Fi.h. You need to download that from the Google. Also this library, ESP82 Web Server.h. You need to download that also from Google. And our ID, or the name of the Wi-Fi, is Bon Jovi. And the password is 123457889. So this is now the main program, software or code. We are declaring the output LED in D4 output. So D4 of the WEMOS Wi-Fi module. So these are the code, and then here this is the user interface, the program's user interface using a web browser, web server. This is the main user interface, or we're going to see that that is the control button. In our, we are going to use a cell phone, since we are talking about the Wi-Fi. And then For the board, we have the Lowland WEMOS D1 Mini clone. Port COM7, upload speed 115,200 baud rate, or the speed rate during the uploading. So this is already, we are already ready. And then from the preferences, you need to this one, ESP, HTTP, Arduino ESP8266 COM stable package, ESP82 COM index JSON file. You need to paste this URL into the preferences here, additional board manager URL. So you need to paste that URL to work with this module. Okay, and then also the board ESP8266, you need to install that. Where can we find ESP8266? So you can see here, where is that library manager ESP8266, and then board manager. Okay, into the board manager ESP8266. So you can see here it is already installed, ESP8266 by community. So you need to install also for the board, and we are now ready to upload the code for our Wi-Fi. Our serial begin uploading. Okay, you can see here it's already done uploading the output. And then by the way, our version of Arduino use is Arduino IDE 2.3.6. that is the version of Arduino we use in our code. Let us now check the result. Now done with the coding. So you can see here this LED now is not blinking, so it is now steady. Okay, because we are already done with the uploading. So how can we check that this module works? By using Wi-Fi and cell phone, smartphone. Let us check if we're going to control we're going to control the onboard LED. That's it. That is the first we're going to do. Controlling this blue LED on board. going to the, or let's see the settings, and then the connection for the Wi-Fi. So you can see here the Bon Jovi. That is our Wi-Fi name according to our coding. Bon Jovi checking the quality of your internet connection. Connect only this time. So it is connected. You can see here, connected without internet. So it means our module serve as a router, but without internet. So it means this is now the receiver and this is now the controller. Okay, cell phone, controller, receiver is the Wi-Fi module. That is the case. So we're going to see that, and then go to the Google Chrome. Since I already checked the IP address, this one 192.168, you can check that in the serial monitor of the Arduino. Okay, 1.4.1 IP address. So this is now the user interface. Wi-Fi LED control on off using WEMOS D1 Mini clone. LED on board on. So this is on. Press off. On, off, on, off, on, off. So we are now controlling the LED of this Wi-Fi module using the cell phone and the Wi-Fi capabilities of this module. On, off, on, off, on, off, on, off. Since we are already done with the coding, we can use external battery, power bank. So you can see here the battery and the module only. Battery in the module, and we're going to control that. Why is it not? Okay, kill the light using the cell phone, and then just the battery, and then the module on. Okay, let us again connect the module. Connect the module. Bon Jovi again. Connected without internet. Why? Because this is now our Wi-Fi router, or we're using a web server. Go back to the control. On. Off. On, off, on. off or on off. So we can control now the Wi-Fi. How can we this? How can we connect this? Because we're going to control this LED. How can we control this? The module, the Wi-Fi, WEMOS connected is the LED. This is the DIY LED connected to the ground and to the D port. So we're going to use power bank. This power bank. Let us now connect to check the okay. The cell phone also. Connection first. The Wi-Fi, Bon Jovi, okay, Bon Jovi, connected without internet, and then the Google Chrome for the IP address. One 192.168 that port, that one. So we have now the user interface. When we press it on, off, on, off. So we now control the LED. So when the LED is on, the built-in LED is off, so they are inverted. When the LED is on, the built-in LED is off. But when the blue LED is on, red LED off. So we now control the LED using Wi-Fi. We have now figure 1 WEMOS D1 Mini clone circuit diagram. So this is our module WEMOS D1 Mini clone. We are using only 3 pins for the ground, and then supply USB. So we are using power bank 5 volts as a supply to the module via USB. And then the output is pin, which is D4, pin out. Connected is the resistor and LED to the ground. So this is the module, LED module, DIY, this part. On board is the blue LED. So what is the operation of the circuit? When we have the cell phone and we press the cell phone, this LED blue turns high. This onboard LED blue turns high. It means it is on. When this is on, the output is off. So if this is off, there's no current that flows into the LED. So this LED is also off. When we press again the switch, when this built-in LED turns low or off, this now pin out becomes high, or it is now on. It is now on. Current now flows into the resistor, the LED red, and then to the ground. They are interconnected, the LED and the ground of the WEMOS. So it means there is an inverter circuit inside this module. When blue LED is on, red LED off. When blue LED off, red LED on. So there is an inverted output. So that's why we can now control the LED using the cell phone, and then the module itself, the Wi-Fi module, and then with the use of power bank as a supply, and the code of the Arduino.